Hi guys, welcome to my YouTube channel. I'm aware that tomorrow you are going to sit for your Combined Science Paper 3. I will provide final exam tips on how to score your Combined Science Paper 3 with flying colors. Before I give you practicals you should expect, I will first give you general tips which apply in any practical exam. You should read the question paper carefully, understand what is being asked and plan your time accordingly. Follow the procedures. You should adhere to the practical protocol provided and ensure you complete all the steps. Measure carefully, take accurate measurements and record them clearly. Record data thoroughly, note down all the observations, readings and results. Analyze data correctly, use appropriate formulas and calculations to earn of the data given. Draw the graphs and diagrams, include clear labels, scale and titles, conclude and evaluate, summarize finding, relate to scientific concept and discuss the limitations. Practice beforehand. Familiarize yourself with practical techniques and procedures. Manage time effectively. Allocate time wisely for each task. Follow the safety protocols, wear appropriate protective clothing, and follow safety guidelines. Check your work, review your results, calculation, and recording for accuracy. So tomorrow you are going to see 2 questions in your exam. Most of the times it is going to be from biology section and physics or from biology and chemistry, but it is not obvious from which sections they are going to select. So be prepared to be examined in any of the 3 sections of combined science. So first I'm going to provide the final exam tips under the biology section. So for Zimsec June 2024, be prepared to answer a practical question on osmosis. This is a frequently examined practical because the materials used can be easily accessed by all schools in the country. There is no way they are going to examine you on microscope because they're expensive to buy, therefore not available in all the schools. So on osmotic practical tips, the materials which are frequently used are potato cylinders, distilled water, solutions with different concentrations. These different concentrations can be salt water or a sucrose solution. So what is very important in this practical is you should measure the initial length of each of the cylinders provided. Either they can examine you to measure the length or the mass of the cylinders. You need to place each cylinder into different solutions and make sure that you label the solutions correctly. For example, you label it distilled water, salt water, sucrose, or you label it A, B, C, D according to the instructions which you are given. And also, you need to leave the apparatus to stand for a given period of time. Use timer to ensure that you leave the potato chips in solution for correct amount of time. After the given time, you should measure either the final length of each cylinder or the final mass of each cylinder and record clearly and neatly. You should calculate the change in length, analyze your results and draw conclusion based on your data. Be able to give observation, be able to identify solution which has lost most of water or the solution which has gained most of water. You should be able to name the process that led to the change observed, be able to plot the change in length of potato cylinder against solution, suggest ways of improving the experiment, and also understand the concept of osmosis and how it works. So in general, The potato cylinder that are going to be placed in distilled water, they are going to gain water through the process of osmosis, because osmosis is the movement of water from the region of higher concentration to the region of lower concentration through a semi-permeable membrane. So it implies that the potato cylinder is going to have a lower water concentration. So the high concentration of water that is in distilled water is going to move to the potato cylinder, causing it to gain mass or increase its length. So that is what you should know. And also the ones that have lower water concentration, they are going to cause the potato cubes to become plasmolized, because water is going to move out of the potato cylinders to either to the salt solution or to the sucrose solution, leading to the decrease in mass in the initial mass of cylinder that we have at the beginning. And then also on the biology section, you should be expected to be examined on food taste. You might think that it is not going to be examined since it was examined last year in November 2023, but the fact about food taste remains the same. Materials are easily accessed by all schools, and food taste may be twisted. Maybe last year they were asking to taste for different food products which are different from those which are going to be examined tomorrow. Or last year they were testing for fats. This year they will be testing for glucose. You never know. So you should always be prepared to answer a question on food taste. When it comes to food taste, you should know about how to taste for starch. The reagent that is used is iodine solution, which is brown in color. You add iodine solution to food sample. If you observe a blue-black, it indicates the presence of starch. If starch is absent, the brown is going to be observed. And then we should know about how to taste for reducing sugars. The reagent that is used is Benedict solution. You add it to food sample. A red or orange indicates the presence of reducing sugar. If the reducing sugar is absent, the blue color is going to be observed. And also you should be able to taste for proteins. This requires burette solution. You add burette solution to food sample. Purple color indicates the presence of proteins. If absent, blue color is going to be observed. And lastly, on food taste, you should know how to taste for fats. This one uses ethanol. You add ethanol to food sample. A cloud appearance indicates the presence of fats, and if it is absent, we are going to observe a clear liquid. So we are now going to see how the practical on food taste in June 2019 was examined. So this is a typical question on food taste. It is reading: you are required to identify nutrients present in juice eggs. You are provided with 3 baling tubes, a test tube rack, a pair of tongs, a graduated syringe, Benedict solution, hot water bath, juice eggs, solution P, solution R, and access to a clock. Carry out these tests described in table 1.1 below and record the observation and deductions in the table. So first, we have to add about 2 cubic centimeters of juice eggs into a boiling tube and add 2 drops of solution R to the juice. So you should know that if you want to add about 2 cubic centimeters, you are going to use measuring cylinder, and then to add the 2 drops of solution R, we are going to use a pipette. So what happened in this test is solution R changed from brown to blue-black. So it shows that the starch was present. And then after that, 2 cubic centimeters of juice eggs was placed into a clean boiling tube, and 2 cubic centimeters of Benedict solution was added. The mixture was heated in the water bath. So the observation was the Benedictine solution changed from blue to brick red. This shows that the reducing sugar was present. And then after that, 3 cubic centimeters of juice X was put into a clean boiling tube, and solution P was added to the juice. After that, the test tube in the hot water bath was left for about 3 minutes. After 3 minutes, it was poured about half of the contents into another clean boiling tube, 2 drops of solution ARA to one of the portion was added. So this is the observation. Solution ARA remained brown. It shows that the starch was absent. And then 2 cubic centimeters of Benedictine solution was then added to the other portion and heated in the water bath. Benedictine solution changed from blue to green. So it shows that there was little reducing sugar that was present. And then this is how they are going to examine you. They will say identify the solution ARA. So now you know that solution ARA is iodine solution. It is the one that changes from brown to blue-black if starch is present. And then on part 3, it is saying state the color of Benedictine solution. The color of Benedictine solution is blue. So if reducing sugar is present, it is going to be converted from blue to orange precipitate. And then the next one, it is saying state the nutrients contained in juice X. Shows that juice X, it contains reducing sugar and starch, since we observe positive taste for those nutrients. And then on part 5, it is saying suggest one advantage of drinking juice X. Since it is having reducing sugar and also starch, it is going to provide us with energy to do work. And then suggest a possible identity of solution P. So most probes, solution P is an amylase enzyme which have converted starch into glucose, because after putting that solution P, there was negative taste for starch. It means that the starch was converted into glucose. We no longer have the starch. So the identity is most probes amylase enzyme. And then part 7, it is saying state the process responsible for the change that occurred when solution P was added to juice and the mixture heated. It is digestion. And then name the part of alimentary canal where the process mentioned in 7 occurs. So the digestion of starch occurs in mouth, duodenum, or ileum, or small intestines. And then finally on part B, it is saying state N2 precautions that should be taken when carrying out the experiment. You should wear protective clothes, use gloves, avoid spillage, use tongs to handle hot test tubes, handle hot water and chemicals with care. This is another typical practical question on food taste. It is saying in an investigation to taste for protein and reducing sugar, a candidate was provided with the required reagents. Name the reagent and describe the procedures used to taste for reducing sugar and protein. So for testing for reducing sugar, we use Benedictine solution. We add few drops of Benedictine solution to about 5 cubic centimeters of dissolved food solution. We warm or heat gently in a water bath and observe the color changes. And then to taste for proteins, we use burette solution, which is a combination of sodium hydroxide and 1% copper sulfate. We add 5 cubic centimeters of sodium hydroxide to the food sample. We add 5 cubic centimeters of copper sulfate solution and mix, and then we observe the color changes. So on part 2, it is saying table 4.1 shows the results obtained. Reducing sugar, it is blue, and then proteins is violet. So it means that reducing sugar was absent, because if it was present, we're going to observe in brick red precipitate, and violet color, it shows that proteins were present in the food sample. And then under chemistry section, we should expect to be examined on pH. They can provide 3 or more liquids with different pH, and they name it A1, A2, A3. They provide universal indicator solution, universal indicator chart, and also a dropper. Then they ask you to add 2 drops of universal indicator in each and every solution, and then you record color and pH of each liquid. Let's say you observe green, it means that the pH is going to be 7, and the acid-base nature, it is going to be neutral. Or let's say you observe yellow after addition, it means that the pH is going to be 6, it is a weak acid. And then if you observe purple color, the pH is going to be 14, it is going to be strong basic. So make sure that you can state the color of universal indicator, it is green in color. And also you should know other ways of determining acid to base nature. Either use red litmus paper or blue litmus paper. If it is an acid, the blue litmus paper turns red, and there is no going to be effect on red litmus paper. If it is an acid, it is going to remain red. And then you should know that if it is an acid, the red litmus paper, it is going to, if it is a base, the red litmus paper is going to turn to blue. And then if you use a blue litmus paper, it is going to remain blue. You should also know the possible sources of error in that experiment, which is color blindness. The precaution involves handling liquids with care and also wearing protective clothing. Under chemistry, also expect a practical on rate of reaction. Here you will be examined on the effect of concentration, effect of pH on rate of reaction, effect of using catalyst, and also effect of temperature. Either you are going to have marble chips and hydrochloric acid. Measure the mass of marble chips accurately. Use timer to measure time taken for a fixed volume of HCl to react completely with marble chips. Repeat experiment with different concentration. You will be required to record and graph and analyze the results. The higher the concentration, the faster the rate of reaction. So on the experiment of comparing the rate of reaction, you can end up drawing, having volume of gas produced in the y-axis and time in the x-axis, and required to plot your results. And then you are supposed to use the graph to answer the following questions. For example, you can say from the graph, find the volume of gas that is collected after 1.5 minutes. So make sure that you can use the graph. 1.5 minutes is in line with 16. So we write 16 cubic centimeters. Then the next question is saying compare the rate of chemical reactions after 2 minutes with that at the beginning of the experiment. So in X, after 2 minutes, 20 cubic centimeters of gas was produced, and in Y, after 2 minutes, 30 cubic centimeters of gas was produced. So this implies that in X the rate is lower, and in Y the rate is higher. So this is what I mean. After 2 minutes here we are having 20 cubic centimeters, and then here after 2 minutes we are having 30. So the rate in Y is higher than the rate in X. And then they will say, suggest the role of copper in the experiment. Copper is acting as a catalyst that speeds the rate of reaction. And then state one other factor which would affect the rate of chemical reaction. So if you use powdered zinc instead of chipping, it is going to increase the surface area, which increases the rate of reaction. And also, if we increase the concentration of sulfuric acid, it is going to increase the rate of reaction. And also, if we increase the temperature, it is going to increase the rate of reaction. So on the chemistry section, you can be examined on comparing reactivity of two metals A and B by reacting with dilute hydrochloric acid. You are going to be provided with test tubes, thermometer, test tube rake, measuring cylinder, hydrochloric acid, and also metals A and B. You add same volume of dilute HCl into the test tubes, and then you add the metals. You record the observations, measure the temperature, and also compare the factors that should be maintained to make comparison clear. You should know the general product, state 1, which is more reactive, and the precaution that need to be followed. So you should always know that the one that is higher in the reactivity series is more reactive than the one that is below another one in the reactivity series. So it means that the one that is more reactive, it is going to produce more number of gas bubbles than the one that is less reactive. So that is what you should know under chemistry section. Then finally, you should know practicals that are most likely to be examined on physics section. You can be examined on comparing densities of different liquids. This one is simplest. You measure the mass of empty beaker and record on table. You measure volume of water and pour into the beakers. Record the mass of water and that of beaker. Calculate the mass of water and then repeat the procedure. Be able to calculate density. Density is equals to mass over volume. You get all your marks by doing correct substitution and giving your answer in grams per cubic centimeters. And also you should know the source of errors in such an experiment. For example, the parallax error. You should know the way of improving the parallax error. And when they ask you to suggest the way of improvement, make sure that you link improvement to error mentioned above. And then lastly, we should expect a practical of measuring resistance. So this is how they can examine you. Fig 2 shows a circuit diagram of apparatus to be used to investigate the effect of varying current on the voltage across a fixed resistor. Correctly draw in the rheostat a variable resistor and voltmeter in gaps 1 and 2 on Fig 2 to complete the circuit. So it is very important to know how you connect the voltmeter, the ammeter in the circuit diagram. And then on part 2, it is saying describe how you would use components in Fig 2 in this investigation. So you close the switch, you switch on the current, right? And then take ammeter and corresponding voltmeter readings. You should vary current by adjusting the rheostat. And then to get several ammeter and corresponding voltmeter reading, repeat the experiment. So what I'm explaining, it was in June 2019. You are required to determine the resistance of a wire R. Fig 2.1 shows the circuit diagram for the circuit which the supervisor set for you. So you're supposed to place one cell in the cell holder, close the switch and record the voltmeter and ammeter reading. Repeat the procedure, adding one cell at a time until you use the 4 cells. So this one is an experiment on Ohm's law. So want to prove that if we increase the number of cells, the voltage is going to increase, and also the current is also going to increase, because we are doing an experiment on Ohm's law, which says that voltage is directly proportional to the current. So you should make sure that if you are given such a question, you complete this table correctly. Voltage is supposed to be at least 1 decimal place. There's supposed to be a correct trend of voltage being directly proportional to current, and after that you should be able to plot a graph of voltage in the y-axis against current in the x-axis. So make sure that you label correctly. Voltage is in the y-axis and current in the x-axis, and also show that voltage is going to be measured in volts and current in amperes. And then after that, they are going to ask you to find resistance. So you should know that resistance is the gradient. We say change in y over change in x, so that is voltage over current. And in this case, if we say 4 minus 1 divided by 0.8 minus 0.2, we are going to get 5 ohms, because it is a matter of calculating resistance. For example, if I take this from this point to this point, the voltage is going to be 4 minus 1, and then for current it is going to be 0.8 minus 0.2. So I'm going to obtain the answer is 5 ohms. So this shows that current is directly proportional to voltage. This marks the end of our tutorial today on final exam tips on combined science paper 3. Thank you so much guys for following me on this channel. Please don't forget to subscribe, like and share my videos. I love you all. This is Eve signing out.